In this video, I'm going to walk you through some of the homework that's due for Chapter 7, and I'm going to use Excel to answer the problems. Okay, in our first example, we have $100 being deposited at the bank, and we want to know its future value 1 year later. Okay, so what I'm going to do is I'm looking for future value, so I'm going to go into Excel. I'm going to click on Formulas, and I can click on Financial and go down to FV, Future Value. That brings up this nice box here, and so I'm going to just plug in the parameters. Our interest rate is 2%. The number of periods, it's only 1 year later. Payment, there is no payment. Present value is 100. And type, I'm going to leave blank. Payment and type have to do with annuities, which we're going to talk about later. This is a single sum. We have a present value of it, and we're trying to find the future value. Now, we already know that it's going to come out to $2, right? That's 2% of 100. All right, one little trick here for Excel is I sometimes will put a negative in here. The reason is that Excel is looking at cash inflow, outflow. So if you put in 100, then you're going to be taking out 102. So because I like to deal with just the positive numbers, I will add a negative to one of the fields. That gives me my answer of 102. I'm going to go ahead and put this in here. The next part of this is telling me to pick out the timeline that best represents what's going on here. So it looks like we know t equals 0 is today. At t equals 0, I have a present value here, and I'm looking for the future value. So therefore, this is the correct one. Okay. Now, we are going to receive $1,000 at the end of 2 years. So we know the future value is $1,000. You can earn a 6% rate of return on your next best alternative. How much are you willing to invest today so that I can have $1,000 at the end of 2 years? So I'm going to come over here. I'm going to click on Formulas, Financial, and in this case I'm solving for present value. I want to know what I have to put away today to get $1,000 in the future. Rate, they told us it's 6%. The number of periods, it's 2 years that we have to wait for the money. There is no payment. This is not an annuity. Future value is known. I'm going to put a negative in front of it, $1,000. And type, it's not an annuity, so I don't have to fill that in. So if I put away $890 today, then I will have $1,000 at the end of 2 years. Now, which of the timeline makes sense here? We do have 2 years. There's a single sum at the end that's known. Future value is $1,000. We're trying to find the present value of that. So I'm looking at C, and C looks appropriate to me. We got T equals 2. Discounting, we're going backwards. Future value to present value is discounting. So I'm going to click that one. The reason D is incorrect is that we have 2 payments, $1,000 at the end of year 1 and $1,000 at the end of year 2. In our case, we only have a single sum, $1,000 at the end of year 2. Okay, a similar problem is $600,000 is invested. How much will they have in 5 years? This will be a future value. We want to solve for future value. Formulas, future value. I am going to earn 6%. Oh, shoot. Well, it's compounded annually. Okay, that's okay. If it's compounded anything other than annually, I have to do something to that interest rate. So we're still good. 6% is the annual, and it's compounded once a year. Number of periods. 5 years, 5 periods. Payment, none. This is not an annuity. Present value is known, 600,000. I'm going to put a negative in front of that. And there's my answer. I'll have over $803,000. Now, I'm wondering, okay, there I see the directions from Mal. How do I do the rounding? Round your final answer to the nearest cent. So 803, 825. Oh, goodness. Well, what's going on here is it is looking for a number that's related to the present value table, the future value table. Okay, so I'm going to solve this using the table, and let's see what happens. Okay, when I use the table, I have to click on the correct table. In this case, I'm solving for future value of a single sum. That's this one right here. It's the top one. I need an interest rate and the number of periods. So I'm going to click on here. The interest rate is 6%. The number of periods is 5. So I go to 6%, go across 5 years, and it looks like 1 point. Let's see if it'll let me. Good, I can just copy and paste that. I'm going to put that here. All right. When I use the tables, all I'm going to do is multiply the principal, 600,000, times the factor that's indicated. Oh, a slightly different number. Let's see what happens when I put this one in. 802,938. Okay, so here Excel and the tables have different outcomes, and it ends up being, I'm wrong, according to Mal, but I wasn't wrong. I used Excel to solve the problem. I'm going to have to go back and make adjustments to make sure that there's enough wiggle room in the answer so that if you use Excel, which gives you the more precise answer, you will get it correct. So that's it for the very beginning of this. Let's see, I guess we can pick the timeline. We are solving for future value. We know present value. Compounding is the term used for going from present to future. We are using 6%, and we do not have a series of payments as it is shown in B and D. So A is the correct answer there. Okay, now we're going to take a break on this video, and I'm going to make adjustments to the answers so that you will get full credit when you use Excel.